Welcome to the ET335 lecture video on shift registers. Registers are used for temporary storage of data and digital signals. So they're made up of D latches where we have a clock signal. This symbol here, the triangle, is a positive edge trigger. So when we want to clock in and store a 1, we put a 1 on data, we clock it in, and it latches in and holds that data. If we want to latch a 0, we put a 0 on our data line and clock it, and it stores a 0. So the register's 1 bit stores either a 1 or a 0, and they are storage devices. So we could transfer the data serially. Okay, all of our clocks are tied together. Positive edge trigger, we put data, and we could clock that 0 straight across. So we get a serial data transmission through our shift register. So parallel data transmission, where we have our register full of information, we clock it and it goes out. All bits are transferred at the same time parallelly. Okay, there's different methods of transferring information in registers. This is serial in, serial out, or SIPO, where we could transfer the information out. We could transfer it and then rotate it back in. And then we could do a left shift where we shift the data and out to the left. Or we could rotate it to the left and then refeed it back into. Okay, we could also shift information parallel. So we have parallel in or parallel out, which is PIPO. So we have data bits, we clock it, and we can store it and then clock it out parallel. Okay, we could also have a serial in and parallel out, SIPO, where we serially transfer the information, and on a different signal we could shift it out all parallel. Okay, we could shift information parallel in and serial out, and this is a PISO, P-I-S-O. So here's a diagram showing serial in, serial out, and we transfer put the information on the data, we clock it, it goes into the first register. We put in a different piece of data, and this time still a 1, and we clock it and we transfer it to the next data latch, and then we put in another piece of data and we could transfer it to the third latch, and then we put data on our first one and we could transfer a 1 all the way through the latches. Here's an IC shift register 74164, which is an 8-bit serial in and parallel out. So we could clear it. Here's our clock signal. So we have serial inputs that we need both at the same time, be 1s, and we could transfer information in, and our outputs would come out in parallel. So it's serial in, parallel out. Okay, here's another shift register 74165, 8-bit parallel or serial in, serial output. So we could put information in either parallel or serial, and we could clock it in, and we have the inputs parallel or serial, and then we could shift them, and we can shift them out. Okay, we could have some continuous shift registers. This is a ring counter where we clock in information and we come out of our queue and we feed it back into data. So we get a continuous pattern that repeats itself. So these are used in communication and digital transfer of information. Here's another type of shift register we could communicate. So what we're coming out of Johnson counters come out of Q bar and we feed it back into data. So we get a pattern which shifts. So we get 4 up, 4 down,